Now let's take a look at some geometric sequences. So a geometric sequence, like an arithmetic sequence, changes by the same amount each time. But in this time, we are going to be multiplying by some constant r. And r is called the common ratio. Also, like arithmetic sequences, they can be written recursively or explicitly. So the formula for the recursive geometric sequence: the first term must be given, and then the nth term of the sequence is the previous term times some number r. The explicit formula for a geometric sequence, in other words, each term as a function of n, a sub n is equal to a sub 1 times r to the power n minus 1. All right, let's look at an example. So we'll write the recursive and explicit formulas, and then we'll find the seventh term in the sequence. Now, this question tells us that it's geometric. So first we need to find r. And like the arithmetic sequence, where we took consecutive terms and subtracted them, now we're going to take consecutive terms and divide them. So the second term divided by the first term. So r in this case is -3. Now just to verify that it can be any two consecutive terms, let's take these two terms. We'll take the second one, or the second one that we found, and divide it by the first one, and we get the same result. Okay, so let's take a look at the recursive formula first. So the recursive formula, a sub 1 is given to us and is -2. So a sub n is equal to a sub n minus 1 times -3. And this is the recursive formula. Remember, in the recursive formula, we have to be given the first term, and then to find the next term, we take the previous term and multiply by -3. Now let's look at the explicit formula. The explicit formula is a sub n is equal to a sub 1, which in this case is -2, times r, which is -3, to the power n minus 1. So this is the explicit formula. So we're asked now to find the seventh term in the sequence. If we want to use the recursive formula, we will have to find the second, third, fourth, fifth, and sixth terms first. Then we can find the seventh term. For the explicit formula is a function of n, so we can easily find the seventh term in the sequence. So let's use the explicit formula. So in this case, n is 7. So the seventh term in the sequence is -2 times -3 to the power 7 minus 1. And so we can do this in our calculator. So the seventh term in the sequence is -1458. Now let's look at an algebraic example. Okay, this is telling us that it is geometric. So since we know it's geometric, we can look for r. Now we'll just take consecutive terms. I'll take the first two. So 6x to the power 5 divided by -3x squared. And so we'll divide 6 by -3 and get -2. And when you divide like bases, you subtract the exponents. So this is x to the power 3. Okay, so the recursive formula is a sub 1 is given. In this case, a sub 1 is negative 3x squared. This is the first term. And to find the nth term, we take the previous term and multiply by r, which in this case is negative 2x cubed. Now let's find the explicit formula. Explicit formula is a sub n equals a sub 1, which again is negative 3x squared, times r, which is negative 2x cubed to the power n minus 1. Now to find the seventh term in the sequence, let's use the explicit formula. So n is 7, so we have negative 3x squared times negative 2x cubed to the power 7 minus 1. Well, 7 minus 1 is 6. And so now we're going to have to use our exponent rules. So this negative 2 has an exponent of 1. And when you have a power to a power, you can multiply the exponents. Okay, so we have negative 3x squared times negative 2 to the power 6 times x to the power 18. Whenever you have a negative number to a power, you need to put it in parentheses. And so what is negative 2 to the power 6 is positive 64. Okay, so now we can simplify this further. We can multiply the coefficients together. So negative 3 times 64 is negative 192. And when you have like bases being multiplied, you add the exponents. So this is x to the power 20. And so this is the seventh term in the sequence. Okay, let's do one more problem as a review of sequences. So we're asked to find the ninth term of this sequence. We are not told if it is arithmetic or geometric. So we need to determine that first. So let's first figure out if it is arithmetic. So we are going to take consecutive terms and subtract them. So 1/3 minus 5 over 6 is negative 1/2. And now we'll try it again with the next two terms. Okay, we got negative 1/5. These are not the same. So this is not an arithmetic sequence. Okay, so now that we know it's not arithmetic, let's check to see if it is geometric. So we'll take the first term and divide it by the second term. So we can keep change flip. So this is 1/3 times 6 over 5. 3 goes into 3 once, twice. So we end up with 2/5. Okay, so now let's check the other two terms. 2 over 15 over 1 over 3. We'll keep change flip. 2 over 15, oops, times 3 over 1. Okay. 3 goes into 3 once, and into that 5 times, so we end up with 2/5. So this is geometric. And the ratio is 2/15. So since we're looking for the 9th term, I'm just going to write the explicit formula. So the explicit formula, a sub n, is equal to a sub 1, which is 5/6, times r, which is 2/5, to the power n minus 1. Okay, so first I'm going to find the decimal equivalent, which is what your questions are going to be asking in Delta Math. And actually, your calculator won't be able to convert some of these into fractions. But since we're smarter than our calculators, we can do it. Okay, so let's see. 5/6 times 2/5 to the power 9 minus 1. So let's go ahead and put that in our calculator. So 5/6 times 2/5 to the power 8. And we get this very small number. Now, if I try to change this back into a fraction, your calculator can't do it. What is that? 4/6 times 10 to the -4th. In other words, it's 0.000546. And so there's your answer. All right, now let's find the exact value. Okay, so we have 5/6 times, now let's just go ahead and multiply this by 2 to the power 8 over 5 to the power 8. So in our calculator, 2 to the power 8 is 256. Oops. Over 5 to the power 8, which is 390,625. And now we'll go ahead and multiply 256 by 5. And we'll go ahead and multiply this by 6. We get this big old number, 234. 3715. And so these are actually the same thing. So we can just prove that to ourselves. Okay, we got the same thing. So sometimes your calculator has trouble converting large fractions from decimals, but you can do it. All right, so that's it on geometric sequences.